Yo, what's up, guys? We're back, day 12. Um, Probably just gonna look at one problem today. I did look at some earlier today. I did a little bit of recursion and things like that. Um, Kind of want to go through problems that I've already solved. Um, just to see, if I can kind of remember the solution. So, remember the solution. I can, complete it and apply the knowledge and everything that I've learned. So we're gonna try and do like 3 problems. What I'm gonna do is like revisit problems though. Depending on how fast we get through them, if I can do them pretty easily, then we'll move on. But we'll begin with like one problem. Gonna go to the very beginning. When I started over here, I do need to practice some stack problems. I'm not very good at using a stack, so that is something I definitely need to practice again. But maybe we can go back and finish that cocoa eating bananas problem that we still have to finish, which I think comeback problems. So we were doing this one yesterday. I'm not the best with grids, so I don't want to continue with that one, but let's go back to this binary search problem here with the cocoa eating bananas, and let's see if we can revisit that problem after a little bit of time. We can go through and just kind of reinforce our knowledge from the past few weeks. This was a tough problem to wrap my head around when I was doing it. I couldn't seem to understand, from memory, how we were looking for the piles. We've got our astronomical object of the day. I got the list here. Palace. I did look at this earlier. It is. I actually originally thought it was a planet, but it's actually a asteroid. So that's pretty cool. Its estimated volume is equivalent to 507 to 515 kilometers in diameter. Wow. Third largest asteroid in the solar system. So that's cool. We got some pretty cool ones coming up in the next few days, so that should be interesting to look at. But anyway, let's get back to this problem. So each feet of K, each hour she chooses a pile of bananas and eats K bananas from that pile, if the pile is this. Okay, here we have our helper function. We define our left and our right. Okay, we have our while loop. So we have our list, our piles here. What are we returning again? Return the minimum integer K such that she can eat all the bananas within H hours. We're looking for them. Our right is the max number in piles. So we're trying to compare from the max value left is equal to 0. Okay, to 0. And so we're using the binary search to calculate that specific value that'll be to achieve this? Well, to find the specific banana eating rate an hour. I'm thinking, how would we calculate that? Paint. So we're starting our binary search from 0 to 30. Alright, we're going to go through this. We're going to loop. So what we have here, we're going to loop through for iron piles. But why are we looping through the piles though? What is H again? I don't even know. H is... Oh, they're coming back in H hours. Okay. I'm trying to think about how to approach this problem, and I don't... Okay. You see... This is so confusing to do, man. I find it so hard to like talk while I'm doing this. While I'm thinking so hard, like my brain's using so much power to think, like crazy, bro. If Coco can eat bananas this speed. Getting so many messages, man. Oh my gosh. Mid is equal to mid. I don't think I'm locked in right now, man. I'm just not locked in. That's such a long day. I don't even know how to like even think about this, bro. Like, and I feel like that's just the worst part. If I can't understand it in my head, then I can't like put it in, execute it. Like, I just don't understand the problem, what I'm trying to do. Let's take this off. Ow, dude, my leg. Can't handle speed. The games. Okay, bro. Fuck this, man. I'm watching a video. I cannot understand this problem. I cannot understand why.
Hey everyone, welcome
Bro.
to more Leetcode today. So today let's solve Coco eating bananas. But before we do, I just want to say that if you do have any requested problems, you can feel free to leave those in the comments. I do have a large backlog of requested
So
problems
frustrating, bro. Like,
so it may take some time for me to get there, but you can feel free to request at any time. And if you find this video helpful, don't forget to leave a like and subscribe for more videos. So this is a pretty interesting problem because there is a brute force solution that we can arrive at, and that brute force solution can easily be transitioned into a binary search solution, which is the optimal solution for this problem. So we're going to be working our way from the brute force to that binary search solution. So Coco loves eating bananas, and we have n piles of bananas given to us in a piles input array. We're also given a second parameter, h, which is the number of hours that we have in order to eat all of the bananas. So we have to eat them within h hours. And so Coco has a certain eating speed where she can eat a certain number of bananas per hour, and that variable happens to be k, and k is not an input variable. That's what we're trying to determine as the solution for this problem. Each hour, she can only choose one pile of bananas and eat k bananas from that pile. So that's what we're trying to determine, that k value. If the pile has less than k bananas, she'll eat all of the bananas, but she's not going to eat any extra bananas from a different pile. So what we're saying here is Coco can only eat at most one entire pile of bananas in a given hour. So what does that tell us? Already we're given some key information. Let's say we're given a certain number of piles, right? So basically the length of p, h must be greater than or equal to the length of p. Why is that? Because let's say we have 5 piles, right? So let's say we had 5 piles, and let's say this is what the piles look like. The values aren't too important, right? 1, 1, 2, 2, 3. And let's say we had h equals 4 hours. Well, let's say k equals some really big number, like 3, right? Basically the max of this input array. Okay, Coco ate this entire pile, Coco ate this entire pile, this entire pile, and this entire pile, because she could only eat 4 piles because we only have 4 hours, right? Coco can only eat 1 pile per hour. So if she ate all 4 piles over here, we'd still have 1 left over. That's why they guarantee us that h is always going to be greater than or equal to the number of piles. So the minimum in this problem, given this input array, h, the minimum it could possibly be is going to be 5. And I sort of wrote over it, but the last important thing that they tell us in the problem is we want to determine that eating speed k that Coco is going to eat at, but we want to know the minimum integer k, the minimum eating speed of Coco, that she could eat all of the piles in exactly 5 hours, or exactly whatever that time interval, that number of hours happens to be. So let's take a look at this example. They give us an input array of 4 piles, and they give us 8 hours to eat all 4 of those piles. What's the minimum k, the minimum eating speed that Coco could use to eat all of these piles in at most 8 hours? So we have to eat all the piles in 8 hours or less. Well, the brute force would be to start at 1, right? Because Coco could try k equals 1, right? Can we eat all piles in 8 hours then? Well, it will take us 3 hours to eat the first pile, right? 3 divided by 1, which is our k, right? 3 divided by 1 is going to be 3 hours to eat this first pile. And to eat the second pile is going to be even more. That's going to be 6 hours, right? 6 divided by 1, 6 hours. So far we already have 9 hours, and we haven't even eaten the entire number of piles. So therefore, k equals 1 is not going to work. And we could just continue this brute force approach, right? Now try k equals 2, right? And then do the exact same computation with k equals 2. Now my question to you is, we know that the minimum possible solution would be k equals 1, right? K can't be 0 because that would mean we're not eating any piles. So the minimum is 1. What's the maximum that k could possibly be given this input array and given this number of hours? Well, remember, the number of hours is always going to be greater than or equal to the number of piles. So in the worst case, k would basically be the max number that happens to be in our piles. For example, if k equals 11, right, that means we're able to eat the max pile in exactly 1 hour, right? And if we can eat the max pile in 1 hour, that means every other pile is also going to take us only 1 hour. So therefore, we're going to eat every single pile in 4 hours. And we know for sure that this is going to be less than whatever is given to us as h, right? We guaranteed that at the beginning. So really what we're doing here is we're going to try every single value from 1 all the way up to 11, which happens to be the max value of our piles. And the first value that we get that allows us to eat every single pile in less than or equal to 8 hours is going to be our output. So we're going to end up trying 1, we're going to end up trying 2, we're going to end up trying 3, and we're going to find that 4 allows us to eat all the piles in less than or equal to 8 hours. So this is not a terrible solution, right? Even though we're brute forcing the entire solution set, 1 through the max of piles, it's not going to be terrible. What's going to be the complexity of that? Well, we're potentially going to have to iterate through every value in this potential solution set. What's that going to be? Well, 1 through the max value of our piles, right? So it's going to be, let's say, big O of the max value of piles, so max of p, multiplied by the length of p, because for every k value, we're potentially going to have to try, okay, if I eat all these, how many hours is that going to take me, right? So we're going to have to iterate through this entire array for every k value that we try. So we're going to get a time complexity of max of p multiplied by p. Right, but that's only, we're getting this max p from the fact that we're having to iterate through every single value in this k range. But why should we iterate from 1 to the end of that k range? Why, in which case, in the worst case, we'll have to go through every single value. Why don't we instead apply binary search on this k range? What's that going to give us? Well, we can reduce max of p to the log of max p. So if we can improve this, this is what our time complexity is going to be. Okay, so I ran out of room, but this is the improved time complexity. Basically, we're taking this variable and applying a log to it, which is going to reduce it a little bit. So let me show you quickly how that binary solution is going to work. It's pretty straightforward, and then we're going to jump into the code. So we're going to be using binary search. We're given this input array, and we want to eat every single pile in less than or equal to 8 hours. So we know that the potential rate that we're eating bananas at, k, is going to be between 1, that's the minimum it could possibly be. The max it could possibly be is going to be whatever the max in our input array is. We know the max value is 11. We can find that in linear time. So then we're going to initialize a range like this, right? This entire range that we have going all the way from 1 to that max value 11. So in other words, we're going to have a left pointer at the minimum and a right pointer at the maximum. Then we're going to compute the middle by taking the average of left and right. 1 plus 11 divided by 2 is going to be 6. So our middle is going to be here. In other words, our k that we're trying is going to be here. This is the rate that we're going to eat bananas at. So we're trying the rate of 6. Does this work? Can we eat all these bananas with a rate of 6 bananas per hour in less than or equal to 8 hours? Can we do that? Well, how many hours does the first pile take? Well, 3 bananas, right, divided by the rate, which is 6, is going to round up to 1. That means it took us 1 hour to eat the first pile. The second pile, 6 divided by 6, is also going to take 1 hour. So let's just count the number of hours. So the second, or rather the third pile, 7 divided by 6, is going to round up to 2. So that's going to take 2 hours. The third pile, 11 divided by 6, is going to also round up to 2. That means 2 hours. So
is it high? No, low. Look through every value in piles. Oops, this must be left. Left and right. I don't think we're meant to.
did this in 6 hours, right? Is that good? Does that mean we found our solution? Well, 6 is less than or equal to 8. That means we were able to eat this entire thing in the time threshold with a rate of 6 bananas per hour. Is this our solution? Well, remember, we were looking for the minimum K value that allowed us to do this. So this might be the solution, but let's try all the smaller values, or let's start our binary search in this direction to see, is there a smaller value than 6 that we can use for our K value? So basically what I'm doing here is, if we're able to eat the entire pile in the threshold, what I'm going to do is then start searching in the left direction. So what I'm going to do is take my right pointer and shift it to K minus 1, because now we're searching this entire range. What if the opposite was true? What if I tried this K value, but I was only able to eat the entire banana pile in, let's say, H equals 10 hours? That means I went over the threshold, right? That means I went over the time. So what does that mean? Does that modify our binary search? Well, what that tells us is our rate of eating bananas, 6, was too small. We didn't have enough time to eat all the bananas in the given available time. So what we have to do is increase our rate of K, right? So in that case, what I would do is I would search the right portion of the range. So what I would do is take the left pointer and set it to K plus 1 over here at the 7. So that's how this binary search is going to be working. But so far we do have one possible solution, and that's 6. So now our new right pointer is pointing over here, and our result is for now going to be 6. So once again, we're going to take the left and right, add them together, divide by 2. That's going to give us 1 plus 5 divided by 2 is 3. So our K is now going to be at this 3 value. So now let's check. Can we eat all the bananas in less than or equal? Said, let's jump into the code now. We know at least this will work. Searching while adding the left and right together, and K, how many pile in the input, which tells us we can add to. We're going to enter the for small 1. So that is in between and subscribe, but if not, that is the entire result of this loop. One.
Why do we have a fucking helper function here? Like, I don't think this is gonna work. Cannot access local variable hours where it's not associated with a value. It's the scope, right? Oh, we have to. Oh my gosh, I'm so stupid. Go to declare outside the loop. Alright. The hours can be incremented. Case want to return if hours is less than or equal to H. We have an infinite loop somewhere, like, or what? I have to piss so bad. Oh my gosh, why is my... I understand that problem, but man, like, bro. Yeah, that was the solution he had. See, I just... I don't... that problem is just so hard for my head to, like, wrap around. Like, it's just insane. Like, alright, let's run through just a couple problems. I really gotta go to the bathroom, so I'm hoping these... Oh, whoops. Hoping these, Pretty good. Did we submit it? Yeah, we did. Okay. Let's just go back to some OGs, like, I don't know. Let's do, I don't know, contains duplicate. Why not? Let's revisit that problem. I'm curious. Contains duplicate. Easy volume. Indonesia array noms. Return true if a value appears at least twice in the array. Return true if every element is distinct. I guess we could just put it in a map, right? A hash map. Hash is equal to I in noms hash dot add noms hash dot add is equal to nums and true else and false. Ooh. Right? No, I already. Yeah. Oh my gosh, dude. Do I just like misspell everything, bro? Oh, please, dude. Dude. Bro, what? Oh, is it the other way around? There we go. There we go. Let's go. Let's see how I did it last time. I honestly can't even remember, like, jeez, we did it October 9th. Wow. It's been nearly a month. That's cool. I'm just curious how I did it. I don't even remember, like. If I noms, if I not in my set. Interesting. I noms, if I. Okay. Interesting. Alright. Nice. Nice. Should we do... What is... Two strings S and T return true if T is an anagram and of S and false otherwise. T is an anagram of S and false otherwise. What is an anagram? Is that the same thing? go into what is an anagram? I don't even. Anagram is a word or phrase formed by rearranging the letters of a different word. Oh. I guess we can move through this for I in range length. Damn length. I can't even think. Holy. I in range length S. If my dick, I not in my dick, and right in my dick, let's increment my dicky. We just want my dick. Else we just make it equal to 1. Right? Okay. Go to our dictionary. I'm getting so many messages. It's probably a way easy way to do this, bro. Honestly, like. In range T if key error 0. What? God, I got pissed so bad. Oh my gosh. What is going on here, dude? What the hell? If my dick, I in my dick. For range. Am I doing something wrong, man? I don't know. I don't know. I don't know. What is this syntax error? I don't know. What is this syntax error? Please tell me. I don't know. Tell me to access keys error in a case. Oh, I see. S-I. S. It's just a... Okay. Dude, what is going on here, dude? I don't think this is gonna do anything switching it around, but I'm just curious, like, what's wrong with this loop? What's wrong with this? Oh, bro. Really, bro? Really, bro? Really, bro? Oh my gosh, dude. Length S does not equal length T. Return false. What am I missing here, bro? Oh my gosh. Oh my gosh, I'm gonna piss my pants, dude. Alright, I'll be back in a second. 1 second. Alright, I'm feeling better now. Let's get back to this. What is going on here? Okay. We want to decrement. That's equal to 1. Then just want to return false. I think it's gonna give the same 46 out of 51. Yeah. We got we just somehow I don't even know how to do this in Python if the value is bigger. Like, yeah. Should we? Oh, why did I do 1, bro? Okay, I think it should work. Jeez. Oh my gosh, why am I checking S, bro? Like, dude. Really, dude? What am I doing wrong here? I think I gotta put it in here. I don't know what I'm doing wrong. What am I doing wrong? What am I missing here, bro? Like, ABBA. This should be true. This is false. I don't know. It should be greater than or equal to 0, maybe? Yeah, because if it's equal to 0, then we can drop another -1. Oh my gosh, dude. I'm decrementing S, not T. Oh my gosh, man. Jeez. It's like little mistakes like that, bro. Like, that just get you. Like... well, I'm sure there's probably, there's definitely a faster way than the way I did it. What do they do? If length does not equal return for index and set as. If set.count index is not equal to t.count index, return. Oh, that's, yeah. That's not a way to do it. Alright, let's do, we'll do this one more easy, and then we'll do like a medium or something, and then we'll call it. Like, that's probably actually what I'm gonna do now. I'm gonna keep going through the problems and like just keep revisiting them and see, you know, if I can do them. I mean, two sum is, bro, honestly, I mean, dude, okay. So reason the game to code. I mean, bro, this is so simple. Like, to do this, it's like basic stuff. I don't even have to look at the question to do it. At least I think. Let's see. I+1 make thumbs. If thumbs I plus thumbs j is equal to target. We return some syntax here, bro. It's a syntax. Boom, 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 boom. Does that work? Please. Yes, baby, yes. I wonder what the fastest way is to do it. I don't even know what they're doing here. So he's using a... I think that's a dictionary. Yeah. Energy versions I. I mean, ours is of n squared, but whatever. November 6, October 9th. Nice. Alright, let's do group anagrams. Check it out. See if I can remember the solution. And show me the solution. Okay, I got it. Okay. Given an array of strings, group the anagrams together, you can return the answer in any order. Input strings, output bat, nat, 10, 8, et. Yeah, I get confused with how to output it like this. Okay. What's the best way to do this? So I'm thinking return the answer in any order. So I'm thinking we store everything in a dictionary, right? No, actually we store it all in a set. Hash is equal to set, right? No. We store it all in a set. I was thinking we store it all in a set and then we can compare, obviously because it can't hold duplicate values. Maybe not. I don't know if that's a way we can do it here. So in range strings, length strings, hashy dot add yeah, it's called strings I, right? And then we can check for I in range length strings hashy I don't even know if that's staying Apache. If I in hashy and but it's not going to work. Because they're all going to be in the hash set, right? They're all going to be in the hash set, so we can't... Can we... If we put eat in, then 8's not going to go in. Oh, right? Or will it? I don't know. Wait, hashy. I actually don't know. Like, I don't think so, right? Oh wow, they all went in. Okay. See, I thought they wouldn't go in. I thought it was just going to be like one of these, and one of these. But now if they all go in, it's a little different. We can sort them. We can sort them. So if we... How the f do you sort in Python, dude? I always forget how to sort in Python. How to sort a string in Python. Like, bro, That's sorting an array in Python, dude. Oh my gosh. Strings dot sort. Big strings. I just want to see what this looks like. Okay. I think I might know what to do here. We add a rule to the hash here, we sort it. Actually, I don't even think it matters if we sort it here. We add them all to the hash set, right? Can we do this? I don't even know if that's a thing. Oh, sorry, strings, dude, strings. That's what I meant, sorry. Can we sort letters, dude? Bruh. To sort a string. Okay. Dude, I have to ask ChatGPT in Python. What the hell does this do, bro? Okay. New strings is equal to sorted strings. That work? Okay. I think let's print that and see what it looks like. You know, underscore strings. No, that's not what I want. I want to sort at each value. To loop through an array called string and sort each. Oh, jeez. let's get rid of that. Right, let's, okay, do this, right? For I in strings. Okay, this is the sorted value here, but join s. Okay, it's sorted underscore s in hashy. Then sorted s in hashy. I don't know. I can't remember, dude. I can't remember. I have to look at my submission. Can't remember how I did it, dude. Okay, use dictionary for iron strings. I wasn't on the right track. If key in my dig, append I, else. Bro! Bro! I had the same idea. I had the same idea. Bro. I had the same idea. My dig is equal to dictionary. In strings, we do sorted underscore s is equal to join sorted I, right? Yeah, sorted I. Okay, if sorted underscore s in okay, and we just minus codec dot and sorted s, right? And if else, we just add sorted underscore s, no? And I did. Okay. Underscore s dot add I, right? Oh, we return this. Equal to I. Return this as a list, right? Or something. Bro. What is going on here? bro, what is going on here? Like, what is wrong? String object has no attribute append. What? Ah, okay. Okay. To really think about this, Brian strings, we sort. Let's go back. So Brian strings, we sort, right? We join it. If it's in the dictionary, we append it. If not, we create a new list and then we return it as a list. I had the right idea. I was using a hash set, but I don't know if I would have implemented this off the top of my head because I don't really know the syntax like that, but hey, it's alright. Okay. Let's just try and do one more. Maybe it'll be quick. What is it? Top K frequent elements. I got some friends coming soon, so top K frequent elements. Oh man, this one's easy, bro. Just use dictionary. Dictionary. And group I in if my dick in if nums I in my underscore dick, then we my underscore dick, we increment it, nums I plus or equal to 1, else underscore dick nums I is equal to 1. Alright, so we got everything. Now we just need to print our top values. Count is equal to k. While count must be better than O of n log n, where n is the array size. Shit, man. Which means you got to do it in the loop. Oh no, that makes it so much harder. This is a value in values. This will be O of n though, so I don't think it's gonna pass, but I just want to do it just to make sure I can do it, and then we can optimize it just to kind of look at it better. What are they doing here, bro? How to find... Oh. Okay, so for some reason, sorted underscore items, sorted. I don't know how this loops in reverse, but I'll take it because I have absolutely no idea. Key is equal to lambda xx1 reverse is equal to true. I don't even know what any of this syntax here means, not gonna lie. Here so top is equal to item item 0 for item in sorted underscore items decrement by k return top. So I don't think this is gonna pass just because it's not O of n log n. I don't. Oh my gosh, bro. Are you serious? What did I type wrong here, bro? Oh shit. You don't need this. Whoops, my bad, guys. My bad, my bad. Oh, my bad. I don't think it's gonna pass. Will it? Oh, it does pass. Wow. Okay. Sorry. To be honest, I don't know how this sorts. Sorry, my girlfriend's talking to me. I don't understand how this sorts, to be honest. I stores the frequencies of each element and arms converts by digging into a list. Bro. Optimized solution with heap keys, dude. Man. Can you explain the syntax on this line? Going to... Okay. Okay, interesting. So this puts it in an order. This here pretty much takes the second value in the dictionary, which is the value, and pretty much we're reversing it here. Item 0 for item in sorted items. I assume what this is doing is we're starting at item 0 for item. Okay, we're starting at item 0. Starting at 0 for item in sorted items. So we're looping through each item, and I think K is just decrements. But I'm going to make sure. Does this syntax? Oh my gosh, I didn't even copy it, bro. Jeez, man. Is this syntax? This shit goes on forever, dude. I don't give a fuck, man. Might have to take a look at list comprehension. I'm actually not too sure. Okay, let's take a look at our previous solutions. Our submission, sorry. We did this one on October 30th again. Damn, okay. Let's check this solution, and then we can check this one too, because I'm curious. Okay, this is group anagrams. We don't need that. It's okay, frequent elements. Oh, okay, so we did the... Is this in Java? What the... Yeah, bro, that looks awful. That looks awful. We did this one in Python. We did it like the same way, sorted. Okay. I mean, interesting. We did the same way that I thought. It's just... Ugh. Ugh. But yeah. Sounds good. We might keep doing that. We might keep going through everything and, you know, just revisiting every single problem. And then we'll probably keep moving on. But, yeah. But okay. I guess we'll call it that. We went a lot longer than I thought we'd do, but sounds good. Okay. All right. See you guys later. See you guys tomorrow.